Hello, friends. This is Bhattacharjee Sir from Core Chemistry to the Point. Today, our topic of discussion is formulae of hybridization and its application. So, let's get started. Our first formula is I have written down total valence electron of central atom plus total monovalent atoms or groups. Monovalent atoms or groups means those atom or groups who chose valency 1, such as fluorine, chlorine, bromine, iodine, hydrogen, and sometimes alkyl group also, which I have written down rightly here. You can see it. Okay. After that, you need to add negative charge, only the modulus part. You should not add sign along with that. Okay. And you should to subtract positive charge at the end. So this is our formula. Now, you'll understand how to use this formula when I'll take example. But before using it, one thing you should be very careful that when to use this formula. Use it when your species is ions and when you don't know about dot structure. Dot structure basically it will give you clear picture about presence of lone pairs and presence of lone pairs on the central atom is very much needed to understand hybridization. Of course, sigma bond is also required. सो अगर आपको लोन पेयर पता नहीं है, सिग्मा बॉन्ड पता नहीं है, कुछ पता नहीं है, फिर भी आप हाइब्रिडाइजेशन ढूंढ सकते हो. इट्स वेरी अमेजिंग. ओके. नाउ कमिंग टू द सेकंड फॉर्मूला which is I have written down, that is the second formula. It is only saying you just count total sigma bond and total lone pair. So it's very simple. It looks like formula. But the problem is that if you want to really know total number of lone pair and sigma bond, then you need to know Lewis dot structure properly. So use this formula when you are very clear about Lewis dot structure. And also you can use this formula for carbon. Now why carbon? Because carbon has no lone pair. So literally for carbon you need to only count sigma bond, no lone pair. So for carbon, your formula will be only hybridization is equal to only total sigma bond. Okay, this formula is only for carbon. Okay, so this is not a different formula. I am just showing how simple it is to calculate hybridization for carbon. Okay, now we'll go to the application part now immediately. Before that, I want to show you uh, when you get different result of H, that is, which is also called a steric number. And of course, by using formula, you will get this answer. If you get answer 2, your hybridization will be sp. If it is 3, sp2, 4, sp3, 5, sp3d. You can see this, how orbitals I have arranged, because these all orbitals basically present in a shell. Of course, bigger shell, if you want all these orbitals to be present, the minimum shell should be 3. So it is, you can say 3s, 3pz, 3px, 3py, 3z square, like that it will go. So one thing you do need to notice when your answer is 2, you can take s and any p out of the 3, but I have taken z. The reason is very simple. Actually, people consider that molecule is formed in the z-axis. Of course, this is just reference point. You can consider it is taking place on the y-axis also. There is no harm. But when you come to the hybridization 5, that is sp3d, then the orbital d orbital you are taking, it should be dz square. Now, if you want to understand why dz square, you need to realize this orbital basically present on the axis, and it completely fits into the trigonal bipyramidal structure. Okay, so which I'll show it little later below this slide. So like that, if it is sp3d2, then you can see this orbital dx square minus y square I have taken. So I'm not going to discuss in detail about it, but I'm just putting it in your mind. Now, later on, when you come to the geometry part, if it is 2, it is linear. Then for 3, that is sp2 trigonal planar. 4 sp3 tetrahedral. For 5 sp3d, that is trigonal bipyramidal. I'm not going to discuss in detail about it. My only discussion is today the application part. And if it is answer is 6, then octahedral. And if it is uh, 7, that is trigonal bipyramidal. Now, I have made few structures uh, with the model. You can see this. This is the linear shape. I hope you can see this. I'm holding it little better. I don't know. Is it coming in the camera properly or not? Okay, this is the linear. So this basically it is talking about this structure, this structure. Okay. Now coming to the trigonal planar, it is this structure. This is the trigonal planar structure. You can see this. This is the trigonal planar. Okay. Now for tetrahedral, that is the geometry. That is the tetrahedral geometry. Why tetrahedral? It doesn't mean that it has 4 heads. Actually, it has 4 faces. Now, if you can think, one face from this side, one face from this side, and one from the bottom. That is 4 faces. If you just hold this structure, you'll understand much better. Okay. Now, coming to the um, this structure, this structure, I got it. Yeah, you can see this. This is the structure that is trigonal bipyramidal. So, ये है हमारा planar geometry. And this green point, they are basically this point they are mentioning, these 2 points. Okay, this is trigonal planar. Coming to the octahedral structure. So, octahedral structure, it looks like that. It is completely symmetrical structure. I'm just holding it. So, see this. This is the octahedral geometry. Okay, this is the octahedral geometry. And if you want to understand pentagonal bipyramidal, then I need to hold. It is just extension of little bit of octahedral only. This is like that pentagonal bipyramidal. This is octahedral, and one more atom will come here like that. Okay. So model part, uh, we can take it in some other classes and we can discuss in details. Now quickly go to the application part. Before going to the application part, I have to tell you one more important point that you can see this. When you calculate this, what it is called, steric number, and mostly it is going to come out as a whole number like 2, and if it is 2, then sp, then 3, sp2, 4, 5, 6, 7, etc. In maximum cases, maybe you can call 90% or 95% cases, but in few cases you might get fractional. ये देखो 2.5 मिल गया, 3.5 मिल गया, तो ऐसा केस में क्या करें? अगर फ्रैक्शनल आया, immediately you need to add plus 0.5 and make it whole number, nearest whole number. Same case. Now, in few cases, you need to subtract 0.5 and you need to get to the whole number. Now, I'm giving you one rule when to add 0.5 and when to subtract 0.5. देखो 0.5 कब सब्ट्रैक्ट करना है वो ध्यान से देखो. When central atom is carbon, कार्बन जब सेंट्रल एटम होता है, ये वाला कार्बन आई एम टॉकिंग अबाउट, and surrounding atoms are either hydrogen or carbon or both combining together. Okay. So it's basically you need to subtract zero point 0.5 for hydrocarbon, and for rest of the cases you need to add zero point 0.5. Got this point clear? It's the most important point, and mostly you will find people are silent about this particular rule. There is no clear guideline. So I hope you have understood that, and we'll see it in the example how to apply it. Now straight away I'm going to the application part. Now, first of all, I'm going to use the first formula. I just want to show you again this formula. I'm going to use this formula. This formula I'm going to use it. Use this formula. This is in 90% cases I'm going to use this. Okay. So now, now you take for sulfur, your half will come first. After that, you need to take total valence electrons of the sulfur atom, that is 6. There is no monovalent atom. Oxygen is not a monovalent atom. Its valence is 2, so I'll not count it. But of course, I'll count negative charge. This 2 will come. So answer is coming out to be 4. So it is sp3. Okay. Now coming to the next case. So half total valence electron of phosphorus is 5. Now you might be thinking, sir, आपने तो इसको रट लिया तो आपको फटाफट आ जाता है. मैंने रटा नहीं है. एक्चुअली क्या है, ये फॉस्फोरस ग्रुप 15 में आता है. तो जिस ग्रुप में आएगा उसका जो ग्रुप नंबर है वही उसका वैलेंस इलेक्ट्रॉन्स होता है. तो इट्स वेरी इजी. सो 5 एंड ऑफ कोर्स क्लोरीन कम्स in 17, and it's a basically monovalent atom, so I need to count all 6, plus I need to take 1, that is for negative charge. So what the answer coming? Answer is coming 6, that is sp3d2. Okay. Now coming to SF6. Now valence electron of sulfur is, it comes in the group 16, so it is 6. Then fluorine 6, and answer coming out 6, that is sp3d2. For this half total valence electron 6. Oxygen is not a monovalent atom, so I'll not count it. There is no negative charge, no positive charge. So simply answer is 3. There is sp2. I hope you understood all this calculation. Coming to a little more complicated. For this, it's an iron, so 100% I'm going to use the first formula. Nitrogen, valence electron 5. Oxygen is not a monovalent atom, so I'm not counting it. But I'm taking negative charge into consideration, so answer is coming out as a 3. So it is sp2. Coming here, 5. Valence electron of phosphorus 5. There is no monovalent atom, negative charge 3. So it is total coming 4. That is sp3. Coming here, half total valence electrons of carbon is 4. Monovalent atom, hydrogens are monovalent because their valence is 1. It's a 3 and negative charge 1. So it is coming out 4. That is again sp3. Okay. Coming here, half total valence electron of carbon is 4 and no monovalent atom. So answer is 2. That is sp. So it's working very well. Now coming to this case, in this case, since this is a carbon, I need to only count sigma bond. So for this carbon, total sigma bond is 1, 2, 3, 4. So 4, that's why its hybridization will be sp3. Now coming to the next carbon, so let me change the color. Now for this carbon, this red color bond, I am trying to show this is nothing but pi bond. So rule is in a multiple bond, one is sigma, rest are pi. So in this case, I'll count this is a sigma bond, this is one sigma bond, and this is another sigma bond. So there are total three sigma bond. So that's why is hybridization is sp2. Okay. For this carbon, this is sigma bond, but I'm just considering the rest of the bond. That is, this red bond is pi, this another red bond is pi. So there are two sigma bond. That's why this hybridization is 2. That is sp. For this also the same case. For this you can see there are three sigma bond. One sigma bond uh, downside what I'm showing it. Uh, let me mark this pi bond as a red bond. So okay. Now for this carbon you can find three um, uh, blue colored bond, that is sigma bond, and red colored bond is pi bond. So that's why it is 3, that is sp2. For this carbon there are only two blue colored bond and two red colored bond are pi bond. Again I am repeating, in a multiple bond one is sigma, rest are pi. This one sp2, 3 sigma bond, there is again 3 sigma bond, sp2, 3 sigma bond, sp2, 2 sigma bond, sp. Okay. I'll take one more example like this later on. Now coming to the NO2 plus, taking half. Now total valence electron of nitrogen is 5, and for positive charge I will subtract 1. So it is answer coming out to be 2. So it is sp. Now coming here, there is half 5. It is coming out as 2.5. So when it is 2.5, you need to make it 3. Got it? So it is sp2. सो मैंने पहले ही बोला था, अगर फ्रैक्शनल आएगा तो आपको प्लस 0.5 करना है फॉर ऑल एक्सेप्ट हाइड्रोकार्बन. कमिंग टू NO2 नेगेटिव, सो हाफ इंटू 5 plus 1 6, that is coming out to be 3, that is sp2. Here half valence electron of carbon is 4, monovalent 3, so it's coming out to be 3.5. Okay. So now I need to take it to the 4. Again, it is not hydrocarbon. I mean, surrounding atoms should be hydrogen or carbon and central should be carbon. Then only we subtract. Otherwise, always we need to add zero point 0.5. So it is sp3. Coming to this case, half, then 4 plus 3, coming again at 3.5. But remember, this is hydrocarbon. Central atom is carbon and surrounding atoms are hydrogen. So I need to subtract 0.5. So it is coming out to be 3. So it is sp2. देखो ये रूल कैसे बनाया वो मैंने आपको बताया नहीं. ये डेफिनेटली ये डिस्कस करने के लिए हम लोगों को अलग एक क्लास की जरूरत है. Of course, I'm going to do this. So have patience. Today is only about application of the formula. Now coming to this half. Now central atom is carbon. I'm just calculating. ये ग्रीन कलर्ड जो कार्बन दिख रहा है ना, अच्छा ये मिट गया. लेट मी पुट इट टू सम डिफरेंट कलर, पिंक कलर. ये जो पिंक कलर जो कार्बन दिख रहा है ना, उसका हाइब्रिडाइजेशन में निकाल रहा हूं. ठीक है. तो हाफ वैलेंस इलेक्ट्रॉन 4 प्लस दो हाइड्रोजन के लिए ये जो दो हाइड्रोजन दिख रहा है ना, ये मोनोवेलेंट है, इसलिए +2 करेंगे। और दिस इज बेसिकली CH3 इज ए होल एज एन alkyl group and उसका valency is also 1. So I need to add this 1 also. So how much it is coming out to be? Again, you are getting some fractional value that is coming out to be 673.5. So again, you can see this is hydrocarbon. Central atom is carbon and surrounding atom is um, carbon and hydrogen. So it will come out to be 0.5 subtract करेंगे. So it will come out to be 3. So it will be sp2. Last example, that is ClO2. Half 7. Again, it is coming out to be fractional. That is 3.5. But in that case, we'll add 0.5, we'll make it 4. Okay, it will be sp3. Okay, so I hope you have understood the full lecture, and with that, it brings to the end of this session. Hope to meet you in the next class. Until then, take care. Bye bye.